Hi, so in this video lecture we are going to talk about a package in Python, and name of the package is Numpy. It's a very useful package. So using this package we can create arrays like vectors, matrices, or even we can create multi-dimensional arrays and we can work with them. And there are many methods we can apply on these arrays. For example, we can do arithmetic with arrays. So using arrays we can do vectorized computations, that we don't have to use loops at many places to multiply uh, several things one by one. We can use different methods in this NumPy class to do those things more efficiently. So this NumPy is a library in Python which has many classes functions in it. So we'll be talking about some of them. So there's a website www.numpy.org. If you want to know more details or you want to study NumPy in more details, you can go and study material available on this website. We are particularly going to work with this NDArrays class. So NDArray is a class in NumPy. N means n-dimensional arrays. So in this class, we are going to construct our arrays as object of this class, and there are lots of methods available for the object of this class, and we are going to see how we can work with those methods. So let's get started. So let's work here in this interactive window. So in order to use NumPy, first we have to call NumPy here using import statement. So import NumPy as, so if you have, so in this case we will be using this NumPy repeatedly to work with arrays, so it's better to use some short form of NumPy. So this is a Python syntax that if you are importing some file or some library, you can specify some short name that you would like to use for that library. So in this case, as most people do, it's a convention to import NumPy as NP. So now instead of writing NumPy at every place, you can use NP. It's up to you. You can specify any short name here, but this is what most people use. So let's stick to that. Okay, so we have imported NumPy here. Now, in order to work with arrays, we have to construct object from this class NDArray. So this class is in NumPy. So NumPy has many classes and some functions that one can use to handle arrays. So let's define one array with the name of data. So this is going to be an object of NDArray class. So in order to create an object from this class, we have to use this NPy dot, because this class belongs to NumPy. So we have to use name of the library, then we have to use array, and then this array takes input, and that input is your array. So for example, if I want to create this simple array 1, 2, 3, so this is going to be an array of this class. So this is just one dimensional array. You may create a 2, 3, 4 or n dimensional array using this class. So let's create another array. I would call it data2. So this is going to be a 2-dimensional array. So array. So for 2-dimensional array, you are going to have double square brackets. So this one square bracket, so this pair of one square bracket is for 1-dimensional array, but inside this square bracket, if you have more square brackets, then this is going to be a 2-dimensional array. So 1, 2 and 3, 4. So this is now a 2-dimensional array. So since this data is an object of the array class, and similarly data2 is an object of this class, so there's number of methods and attributes we can use for these objects. For example, there's an attribute that determines size of the your array, and there's an attribute that tells you the dimension of this array. For example, let's practice some of those attributes here. So data dot size. So size is an attribute of this data object. Remember, this data is an object of this and the array class. So size is going to tell us the size. So this data has three elements. So size is simply the number of elements in your array. So in the first array we have three elements, therefore size is 3. Similarly, let's try for second array, data to size. It is going to give you 4 because there are 4 elements. And there's another attribute of this object which is called shape. So data dot shape. The shape is going to tell you the number of elements in each dimension. For example, in this case you have just one dimension, and this one dimension you have 3 elements. So if you use data.shape for this array, you are going to get 3. For one dimension array, this shape is going to return this tuple, and the tuple is going to have just one element, and that one element is going to be the number of elements in that dimension. This is one dimensional arrays, and one dimension has only 3 elements. Let's try for data 2. So data 2 dot shape. So the answer is 2 2. Why the answer is 2 2? Because this is a 2-dimensional array. So, and for example, it has in this one big bracket, it has these 2 elements. So that's why we got 2 here. And then each of these 2 brackets we have 2 elements. That's why we have another 2 here. So in other words, the outer bracket determines one dimension and the inner bracket determines one dimension. So in this outer brackets we have just one inner bracket. I mean, we don't have a bracket inside this inner bracket. So, or you can also say that the outer bracket determines one axis and the inner brackets determine the another axis. So that's why in the outer bracket we have 2 elements. Therefore, in one dimension you have 2 elements, and inside this outer bracket we have these brackets, and each bracket has 2 elements. That's why we have 2 here. It's a kind of order of the matrix. If you consider it 2 by 2 matrix, then this is 2 comma 2. But in this case, in the first case, if you consider this is a vector or a matrix, so the order of this matrix is going to be 1 comma 3, because it's 1 row and there are 3 columns, but you get only 3 here because this is slightly different from the order of the matrix. So, but because in this case this is just a 1-dimensional array, you can make it 2-dimensional. So let's try it. Data is equal to, so this was our data. So if you want to make it 2-dimensional, you just have to enclose this in another square bracket. Now you see that the outer bracket has just one element, and this in one element we have 3 elements. So what would be the size in this case? Now let's check data dot size. Sorry, we have to check the shape. Data dot shape. So the shape is 1 comma 3 because the outer bracket has just one element and the inner bracket has 3 elements. So the shape of this array is 1 comma 3. So this is how we determine shape of an array. The shape is simply the number of elements in each dimension, or number of elements in each axis. So we have 2 dimension. The one dimension has 1 element, the other dimension has 3 elements. That's why the shape is 1 comma 3. And size is only going to tell you the number of elements in an array. So in this case the number of elements 3, even though this is a 2-dimensional array, but the number of elements is 3. That's why you get 3 here. There's another attribute for this object, and that attribute is number of dimension. So data dot ndim. Ndim is for number of dimension. So data is this array. So in this case, now that we have 2 dimension because we have 2 brackets, so you get 2. But if you remove this from here, this bracket, now this is just a 1-dimensional array, so you will get 1. This is how ndim works. So there is one more important attribute that is going to tell you the data type of these arrays. So for example, in this case the data type is integer, because the way we have written these numbers, data, the type of data is going to be integer. So for that we have attribute dtype. Dtype is going to tell you the data type of these arrays. So data type of this data is integer. It tells you the integer, 32-bit integers. So we have variations here. Sometimes integers are written in 64 bits, and sometimes they are written in 32 bits. So, but if I change this to these number to, if I add this decimal to every number, so now I have changed the data type to uh, float. So now if I use d type, I'm going to get this float. It says that the data type is float. So in array, the data type of an array has to be homogeneous. Homogeneous in the sense that every entry of the array is supposed to have the same data type. Like they're integer, so 1 is integer, 2 is integer, 3 is integer. So every entry has data type integer. You cannot have different data types in an array. Data type has to be homogeneous. This is different from list. For example, if I have a list L, so list can have like a number, and it can have some string, right? So list can have number of different data types, but this is not true for array. For array, every entry of the array is supposed to have the same data type. For example, in this case, all the data types are float, and you may change the data type anytime if you want. For example, in this case, the data type of this array is float, but I can specify here an optional argument where I can specify the data type I want for this array. So for that we use here the keyword dtype, and here you can specify that you want it to be integer. So it start with np because everything belongs to this library numpy, np.int. So we have specified that we want this data to be of integer type. So now let's run this and see what we get here. So you see that now these values have changed. I mean the decimal has been removed, so the data type is integer. But again you can change it to the float. So let's change it to the float. So now it has integer data type, but you can change it to float. When you run it, and let's check what is inside data. Now you see that you get a decimal point here. So there are a number of ways you can in number of ways you can use this change of data type. For example, now this is data. You can use it here, this data. Instead of listing these numbers, you can simply use its name. So we want this data to have the float or int data type, or you may have complex data type. So for complex data type, you just have to write complex here. Now let's see how the entries look like. You see that now these numbers have complex representation. Though the imaginary part of each entry is 0, but you still get representation in the form of complex numbers. So you see that we have np here and we are writing np here. So you don't have to specify np twice, because when we say np.array, that means we are considering this array from this np library. So we don't have to specify it here. You can simply use it like this. You can simply remove this np from here. So it's going to work. So let's see it has the correct answer. Okay, so we got the same answer. So in this way you can change the data type of your array, but you have to make sure that every entry of your array has to have the same data type. For example, all of them have complex data type. If you don't specify data type of an array, then by default the data type is float. Let's say if you have an array whose data type is complex. Okay, let's consider the same data. So we have this data which has complex number representation. So if you have an array which has entries of complex number, you can always define two arrays from that array, so that one array contains the real part of that array and the other contains the imaginary part of that array. For example, for that we use this real attribute. Real is going to give me the real part. So in this case, this is the real part. 1, 2, 3, they are the real parts. And you can also get the imaginary part. For that we use this keyword image, So this is going to give me the imaginary part. So in this case, all arrays have zero their imaginary parts. So there are a number of different kind of arrays that you may create. For example, if you want to create an array of some dimension which has all entries zero, so you don't have to list entries manually. There are functions available here which are going to create array of a certain dimension with different kind of entries. For example, if I want an array of some size or some dimension which has all entries zero, for that we have zeros function, zeros method available for the array. So let's say if I define a new array, I would call it, let's call it data again, and you have to start with np. Always you have to start with np. Then so after np you have to specify what you want to create. If you would like to create an array of all zero entries, then you can use this zero function available in this np library. So here you have to specify the dimension. For example, I want to create a 3 by 3 array of zero entries. This is how you have to write. So this has to be inside these parentheses. So this is going to give you two-dimensional array with every dimension is going to have 3 entries. So we are going to get this array. So you see that 0 point, you get a 0 point. So there's a decimal point here, because as I told you that by default array is going to have a float data type. Using this you can create array of any dimension with 0 entries. Similarly, we can create an array which has all entries 1. So for example, if I say data np, so I'm using this data for every array, but you don't have to use, you may use any name you want. So np, for that we use ones, and similarly you have to here define the dimension. So this is going to be, let's say we define 3,4. So now let's check what is inside data. So you see that we get 3 by 4 array and all entries are 1 1. Again the data type is float. So if you specify just one integer here instead of this tuple where you have two numbers, so if you specify only one integer here, that means it has only one dimension, and that one dimension has 2 entries. Therefore you are going to get output like this. So let's try again. So data np dot ones, and here you can specify like 4, because you have specified only one integer. That means there's only one dimension, and that one dimension has 4 entries. So you will get something like this data. So you get this answer. But if you want to define a 2-dimension array, then for example, let's make it 2-dimension. In that case, we are saying that the first dimension has only 1 entry and the second dimension has 4 entries. So you are going to get sorry, again I have missed these 2 parentheses. You always have to enclose that into these parentheses. Okay, so you get let's see what we get here. So we get a 2-dimensional array now. So we have converted this into a 2-dimensional array. So Python also allows you to create an empty array. Empty array simply means that you create an array with some dimension, but you don't fill up entries in that array. So let's define an empty array. So let's define a variable data, or you may say that some w is equal to np dot empty 3,2. Again I have made this mistake that this has to be in parentheses. When you run this, so you have defined an empty array. Let's check what is inside y. You see that it seems that there are 0 entries, but they are not actually 0 entries. They are empty spaces. You can't use them, so you can't consider this array with 0 entries because we have defined this to be an empty array. So if you want to call this position, you won't get 0. The Python is going to give an error. So this is not same as defining writing here zeros. For example, we did it here with ones and with zeros. although they have same representation. In that case you have defined that data is going to have 0 entries, but in this case you have defined that this is an empty array. Although Python has represented this in 0 forms, but they are actually empty spaces. But Python also allows you to fill up these entries with some constant number. For that we use fill function. So W is your object. So on this object you can apply this method fill. So fill is now you can fill with any entries. It's your choice. If you want to fill this W with 5, so all these entries are going to be filled with 5. So let's run this and check what is inside W. You see that now all the entries are 5. So there are a number of ways to define arrays which have entries and that are equally spaced. And for example, so let's define an array x is equal to np dot and there's a function, it's called arrange. So arrange with 1r, and here it takes 3 arguments. The first argument is your lowest entry, and second argument is going to be the highest entry minus 1. Let's say you want highest entry to be 9, so you have to specify 10. So values are going to range from 1 to 10 with a difference of, let's say, 1. So values are going to range from 1 to 9 with a difference of 1. So now this is X is an array which consists of 9 values starting from 1 ending at 9. So each value has difference of 1. So let's see that. So when you do that, you get this. You may change it. You may change this to here. Now the values, the consecutive values have difference of 2. So we get this 1, 3, 5, 7, 9. You can't go beyond 9. The maximum is going to be less than 1 less than this number. So we have defined this arrays by defining difference between the two consecutive entries. So there's another similar function. So for example, x is equal to np dot line space. There's a very small difference between these two functions. So this is going to take first entry and the last entry, and here the third argument is different from this argument here. Third argument is the number of entries you want from 1 to 9. Here you're specifying the consecutive difference of the consecutive terms, but here you're specifying that you want equally spaced entries, and let's say you want 4 equally spaced entries. So let's see what you get in X. So you get 1, 4, 7 and 10. So basically there are two differences here, that line space is going to range from 1 to 10. It also includes the last number, so 10 is inclusive here, but here 10 is not inclusive. So and here we create an array by defining the number of values we want from 1 to 10, but here we specify the difference between two consecutive values and create an array. So these are two main differences between line space arrange and line space. So there is another useful function which can be used to draw three-dimensional surfaces. It's going to construct a graph paper for you, grid points on the graph paper, so that you can calculate function value on those grid points. So that function name is mesh grid. For that you have to define what are the values you are going to take on x-axis and what are the values you are going to take on y-axis. Then we take their cross product to make a mesh grid. So for example, we define x is equal to np dot array, and this array is simply has these three values. Let's 1, 2, 3. So you can think this as we have marked 1, 2, 3 points on the x-axis. Similarly, we define y np dot array, and on y we have these values. For example, we have 0, 1, 2, 3 values. You can have different values here, it doesn't matter. Okay, so x and y are two arrays. Now for this you can think that you have marked 1, you have marked 0, 1 and 2 on y-axis. Now you can create a mesh grid. So mesh grid is going to be the ordered pairs. So you are like drawing lines, vertical lines through these points and through these points. So these are the values on x-axis, these are the values on the y-axis. So you're drawing vertical lines through these points, and you're drawing horizontal lines on through these points. So you get a grid, and each corner of the grid is going to represent the points on that mesh grid. And for that we actually use a mesh grid function. So x comma y, that mesh grid function is going to return two arrays. One array is going to consist of x values, and the other array is going to consist of y values. So mesh grid, and here you pass these two x and y values, x and y arrays. So x comma y, so this has to start with np because this is from this class mesh grid. So we have created a mesh grid. Let's see what is inside x and what is inside y. So x is this two-dimensional array and y is also a two-dimensional array. Now let's see how this works. So it has created a mesh grid on xy axis. So first point is 1 0 when x is 1 and y is 0. Second point is 2 0 when x is 2 and y is 0. Similarly, third point is 3 0. So these are ordered pairs on your graph paper, and this is actually useful when we are plotting a three-dimensional surface where function takes value at each of these grid points. For example, let me just write here, if your function f of x, y, x comma y, let's say this value is z, and this is defined as x square plus y square plus 1. This x comma y is this ordered pair, like x is 1 and y is 0. You are going to calculate the function value at these points, and that is going to be z value on z axis. When we have calculated these function values, all these grid points, you get all the z values that you can plot on z axis. So that is going to give you a surface. And you must have discussed these kind of things in your calculus course. You may also create different kind of matrices using some functions available in the Numpy class. For example, if you have to calculate identity matrix, you simply have to use identity function. So np dot identity, and here you can specify the order of the matrix. Let's say we say 3, so you get a 3 by 3 array. So one important point to note here, that here you cannot have a different order. Let's say you can't have 3 comma 2 because the identity matrix is always a square matrix. That's why you just have to input one number. So this is not like the other array functions to, let's say, create array of 0 entries where you have to specify the dimension here. With this kind of syntax where you have 3 comma 2 and 3 comma 4, this is different from those functions. It is specifically designed to create a matrix of some order. You just have to pass one integer argument to these functions. Similarly, you can create a diagonal matrix where you have to just pass a diagonal to that function. For example, np dot, so this is the function np dot diag. So this diag is going to generate a matrix or an array with diagonal entries. You can specify here any diagonal entries 1 comma 2 comma 3. If you do that, you get a matrix with these diagonal entries. Now let's discuss how we can retrieve or call different values from an array that are at different positions using indexing. And you may also slice different part of the arrays for different purposes. So let's define an array. A is equal to, you may define array in any way. You can always list values in an array, or you can generate an array using line space function that we used before. For example, let's generate an array np dot line space, and here we specify, let's say 1 to 10, and we want from 1 to 10, we want, let's say, 3 values or 4 values. So A is this one dimensional array, and it has these 4 values. Now this is the first position. At first position you have 1, at second position you have 4, and first position is always indexed with 0. So in order to get first position, you have to simply write a square bracket 0. You are going to get the first position. If you start counting in this way in ascending order, then this is 0th position, first, second, and this 10 is going to be the third position. Let's see if we get 10. So a of 3 is 10. But if you start counting in the reverse order, then as we did in the list, this position is going to have -1 index. Let's see. So -1 is going to be this 10 index. Similarly, -1, -2, -3, and -4. Let's see what we have at -4. So -4 is going to be the last index if we start counting in the reverse order. Similarly, you can slice some part of the array. For example, if just I want this part of the array, or I just want this part of the array, I can use slicing for that. For example, I just want this part of the array from 1 to 4. So for that, the syntax is we start with this position, and this position is 0, and we put colon here, and then we go to this position, and this position is like first position here. So you have to write 2, because whenever you write like this, Python start with the 0 position, and it goes to 1 minus this position. So 1 minus this position is going to be 1. So if you want to get only 1 and 4, then we have to write like this 0 colon 2. So this is going to give us array of the first 2 entries. But if you would like to use all the entries, then you simply have to use this colon. So colon means take all the entries starting from the lowest position to the highest position. So this will give you the entire. And if you specify the beginning position and you don't specify the ending position, so we are not specifying anything here. So it's going to start from 1, and it's going to take all the position up to end. So here it's going to start at 1 means 4, but it's going to take from 4 to 10 all the numbers. So let's see. So you see that we get this array from 1 to 4 to 10. On the other hand, if you specify the end position, let's say you specify 3 here, then Python is going to start with 0, but it's not going to go up to 3. See, it's going to start from 0, and it's going to end up to 3 minus 1. So the last position is always 3 minus 1. It's going to start with 0th position, and it is going to go to 2. So let's see. So you see that we get 0th position, first position, and second position. Python also allows you to select different entries using your own indexing scheme. For example, you might want to select 1 and then you leave 4, then you want to select 7 and then you want to leave 10. So you can increment your index with any number. For example, if I have this A0 colon 3 colon 1, that means you have to start with 0 and you have to go up to 3 minus 1. But when you start with 0, you have to increment 1 in previous index to get the next index. So 0 plus 1 is going to be first index, and then 1 plus 1 is going to be second index. So you are going to get 3 values here. So if you run this, you see that you get 1, 4, 7. But for example, if you write 2 here, then you start with 0 and you increment 2 in 0, you get second index. But when you increment 2 in 2, you are going to get 4. So that is not available here. So in that case, you are only going to get 1 and 7. So this is at 0th position. So in this position, if you add 2, you are going to get the second index. At second index, you have this 7. So 0, 1, 2. This is your second index, and then you have value 7. So now let's define a two-dimensional array and see how this indexing works with two-dimensional array. So let's define a matrix B on an array B, np dot array, and so I'm going to define a two-dimensional array. So 1, 2, 3, and let's define here 3, 4, 5, and let's define another vector 1, 2, 9. So this is a two-dimensional array. Now let's see how indexing works here. So for that you have to use two index. For example, 1, 1 is going to give you this first entry. So 1, 1 is going to give this 4, the diagonal entry. So this is going to be 0, 0. So first row has 0 index, the second row has first index, and this third row has second index. So if you say 0, 0, so you get the first entry. Similarly, 0, 2 is going to give you 0, 1 is going to give you this second entry. So the first index is your first dimension, and the second index for the second dimension. And similarly, you can slice some part of the matrix, some part of this array. For example, if I say B from 0 to 2, 0 to 1, okay, so 0 to 2, and the second dimension I'm going to get from 1 to 2, so or 1 to 3. So from here you see that you have said that start with 0, that 0th row is this row, and go up to 2. So you are going to go from 0 up to 2 minus 1. So you will get you are considering these two rows, and from these two rows you are selecting these columns from 1 to 2. You don't have to consider 3 here, from 1 to 2. So this is your first column and this is your second column. So in these two rows we are considering these two columns, so we are going to get 1, 2 and 3, 4. Let's see if we get that. Sorry, so we are considering this first column and second column. So first column is this column and second column is this column. So we are going to get sorry, the first column is this column and the second column is this column. So we are considering the first two rows and the last two columns. So we are going to get 2, 3 and 4, 5. Let's see if it works. So we got 2, 3 and 4, 5. As we did in the one-dimensional array, incrementing indices also work in the two dimension. For example, if I say B is going to be we start with the 0th entry and we go up to, let's say, 2 with an increment of 1. And similarly in the second dimension we start with 0 and we go up to let's say we go up to 2 with an increment of 1. So in this case we are saying that select the 0th row, go up to 2. Up to 2 means 2 minus 1 here. So 0 and 1 with an increment of 1. So you start with 0, you increment 1 to 0, you are going to get the second row. Similarly, it says for the column, start with the 0th column and then increment 1 to that column, you are going to get 1. So that's it, because you can't take these two values. So now if you run this, you will see that you are going to get this 1, 2 and 3, 4, first two rows and first two column. But if you don't specify anything here, for example, if you just leave these positions, it says that start with 0. Remember, this was your first position and this was your end position, and this is the increment. So it says that if you don't specify anything here, that would mean that start with 0, the lowest position, go up to the highest. And here start with the lowest and go up to the highest with an increment of 1. So in this case you are going to get the entire array here. So leaving means the default position, So if you don't write here, the default position is the lowest position. If you don't write here, then here default position is the highest position, and this is your increment. So in that case, you are going to get the entire matrix here, or entire array here. Now suppose that if we slice some part of this array and we assign that sliced part some other value, and we want to see if we assign some different value to that sliced part, does it have any effect on the original array? For example, this is over A, sorry, so this was B, sorry, this is, okay, let's define B again. So B is the original array. Now let's say I slice this part of the array. So I define another array, let's call it D, and D is going to have, let's say, 1 to 2, sorry, 0 to 2, and similarly for columns we have 1 to 2. So we are going to get this part of the array. So D has these, so I missed A here, sorry, the name of our array is B, not A. So we have defined this array. Let me just print B again. So this is our B, and we have sliced this part from B, and that sliced part is this 1 2 3 4. Now let me assign some value to that sliced part. So let's say if I assign every entry of that sliced part to 0. For example, if I say, so when I say colon, that means we are considering all possible values here in the rows and all possible values in the columns. If I assign this to some other value, let's say if I assign 0 here, so now D is going to be, D has updated and the values are 0 0. But now let me see if what happened to this original matrix B or this original array B. Changing a sliced part of that array has any effect on the original array. For that, let's print B again and see what happens to B. So if we do that, we see that B has also changed. So because in Python, when you sliced an array and you assign that array different values, so it is going to change the original array because these two have the same address in memory. So because of same address, the changes that you have made are going to be effective on this original array as well, because they are stored at the same address in your memory. If you don't want this to happen, what you can do is you can copy this D array in some other variable and then work with that variable. And for that, we have a copy function for this library. So let's define another variable F, and in F we would like to store this D, and we want to make changes in that F so that it has no effect on the original array. So F is going to be D, and we have to consider the entire D. So for copy, we use this function dot copy. So this dot copy is a function in Numpy that is going to copy this D into F. So there is a spelling mistake here. This has to be copy. So now F is this array. Now if I make any changes in F, that changes are not going to affect the original array B. So if I define F is the entire F is equal to, let's say, 1, and this would have no effect on the original array B. So if I print B, so B is same as before. So this F has not changed anything here. So this is how we can work and copy arrays, and we can extract different part of the array for different purposes. So there are some other ways of indexing, and those ways of indexing, they don't alter the original array, and this is called indexing array with some other array, and this has a special name. It's called fancy indexing. For example, let's say if I create an array age equal to numpy dot line space, suppose we generate from 4 to 15, we want 6 values. So this is going to be your array. Now you can index this array. You can extract some part of this array using some other array. For example, I want to extract from this A let's say I want to extract this value, and this value. So this has index, or you may extract any values. For example, let me just do like this. we want to extract this first value, and then we want to extract this third value, and then we want to extract this fourth value. So what I will do is I will create an array here, array, and that array is going to be that array is going to consist of this indexing that I want to extract. So I wanted to extract this part. This is the 0, 1, 2 second index. And then I want to extract this part. So 0, 1, 2, 3, 4. This is fourth index. And then I want to extract this part. This is fifth index. Fifth. So 0, 1, 2, 3, 4, 5. So now I'm slicing this array A with another array, and that array is nothing but the indices of the values that I want to extract. If you do that, you are going to get, so there I have missed this P from here, and this has to be square brackets because we are extracting values, so we have to use square brackets, not parentheses, because you see that in all these cases we have used square brackets. Okay, so when you run this, you get this. So this was your A. So at second position we have 8.4, so 0, first and second position. And at fourth position we have 12.8, and at fifth position we have 15. So you see that we have extracted some part of the array using another array. So let's call this new array, give it a name. I would call it P. So now if I assign, so P has these values, 1, 2, and 3. There are 3 values. Now if I assign to this P, every entry of P, if I assign 0. So what we have done, that we have extracted some part of A and we have stored that array in P. Now I'm assigning to every entry of P 0 value. So let's see if it has any effect on the original array. Like we have seen before that this was our original array. We extracted some part of it and we assigned to every entry of that part 0. And then we printed the original array. We saw that our previous array has changed. Let's see if it happens here. So now if I print A here, I get the original array. There is no change in it. So if you index your array or you slice your array with another array like this is called fancy indexing. Then if you make changes in the sliced part of your array, that is going to have no effect on your original array. So this is the difference between this indexing and the indexing we did before. There is even another way of slicing an array using some Boolean expression. That is called Boolean valued indexing. For example, this is my A, and I want to construct another array G, and G is going to be some part of A. And here, instead of specifying some indexing that correspond to the slicing part, I can simply specify a Boolean expression. I can say that get all the values which are less than some number or greater than some number or equal to some number. So this is a Boolean expression. I can say that get all the values here A which are greater than 10. So in A we have 4, 6.2, 8.4, and from this onward all the values are greater than 10, 10.6, 12.8, and 15. So these values are going to be stored in G. So G is going to be, now let's print G and see what is inside G. So G has got these 3 values which are greater than 10. So this kind of indexing is called Boolean valued indexing. So we have this Boolean expression here. So Boolean expression is going to get us the corresponding values. Now if I make changes to this G, remember this G is some sliced part of A. If I make some changes to G, let's say if I set all the entries of G equal to 0, so this has to be equal to 0. And now let's print G. So all the entries in G are 0. Let's see if this has any effect on the original array A. So if I print A, you see that there is no change in A. So if you slice your array either using another array, it's called fancy indexing, or you sliced your array using Boolean expression like this, and if you make changes in your sliced array like G here and P here, they are going to have no effect on your original array. It is different from the conventional indexing that we did here. So, but for this also we have a solution that we can simply copy the sliced part in some other array and then work with it. Then that will have no change in the original array. So this is for today. I'm going to end here. So in the next lecture we are going to continue from here, and that is going to be our last lecture on NumPy. Thank you.